Okay, our today's topic is transformer. This is physics. Now, what is transformer? Transformer is a device used for stepping up or down and alternating voltage. It's like I will write. A transformer, a transformer is a device used for stepping up or down and alternating voltage. Are you there? Good. Now, before we dive into the concept of transformer, we need to understand the structure of a what? Transformer. The structure of a what? Transformer. The structure of transformer. The structure of transformer. Is this marker visible? The structure of a transformer. Transformer has three structure. It has how many structure? Three. One is it consists of two separate it consists of two separate coils. Are you there? And they are primary coil and secondary coil. Are you there? Now, two, I. The primary coil is an input winding turn. Are you there? The primary coil is an input winding turns. Are you there? And the secondary coil is an output winding turns. The last but not the least in the structure of transformer is that here here is where we talk about the laminated soft iron coil. Here we say that the coils are wound, or you say are wounded. You understand now? Are wound round the laminated, are wound round the laminated soft iron core. Did you understand now? Now, another thing we need to look into here is the principle of operation in transformer. The principles of operation in what? In transformer. We have principle of operation in transformer. Principle of operation. The general principle of operation in transformer. One is that the AC source is applied at the terminal core, at the terminal primary core, is applied at the terminal primary core. Do you understand now? Now, II. Here you say the alternating flux. The alternating flux is produced in the iron core. Is produced in the iron core. Are you there? Which links the secondary coil? Which links the secondary coil? Are you there? Good. Now, the third one, which is the last one, the last principles of operation here is that the alternating EMF is as is of the same frequency as applied at the primary coil. Is at the same frequency applied at the primary coil, which is induced in the secondary coil, which is induced in the secondary coil by mutual inductance. By mutual what? Inductance. By mutual what? Inductance. So now another thing we need to know is induced EMF in the secondary coil depends on the EMF in the primary coil and on the number of and on the ratio and on the ratio and on the ratio of the number of turns, TURNX. Are you there? Now here, let's talk about the terms in transformer. We have EX, E subscript S. This is called induced EMF in the secondary coil. YEP is applied voltage in the primary coil. Are you there? We also have NX, N subscript X. Are you there? We also have N subscript X. N subscript S means number of turns in the secondary coil. Here, you can also call this applied EMF too. Call this applied EMF, not voltage, applied EMF in the primary coil. YNP is number of turns in the primary coil. We have VP. VP means input voltage. You can call it input, power output and power input. So you can call this power input. Are you there? You can call this power input. While Vs is called power output. Now look up. Here now, it is Nx over Np equal to, no, you can also say Es over Ep. Are you there? Es over Ep equal to Ns over Np. Are you there? We can say this is Ex over Ep equal to Ns over Np. They are the same thing. Do you understand? So here you can say or Vs over Vp equal to Ns over Np. Now, I want to do something down here because we still have space here. I want to show you something down here. Now, applying the law of conservation of energy. Applying the law of conservation of energy in an ideal transformer, with 100% efficiency. When you apply the law of conservation of energy in ideal transformer with 100% efficiency, mind you that no transformer has 100 efficiency. Are you there? So if you are to apply that, here we are going to have something like ISES over ISES equals to IPEP. That is ISEX equal to IPEP. What is this I? Secondary current. Are you there? Why this one is what? Primary current, induced secondary current, and this one now applied EMF current there. Do you understand the point now? You can also have something like having ISES equal to IPEP. You can also have ISVS, that is mirroring this formula here. You can have ISVX equal to IPVP. Already we know what VS is, power output, while VP is power input. IS is induced, IS is current, secondary current. This one is what? Primary current. Current in the secondary coil, while this one is current in the what? Primary coil. We can say here where IS is equals to current in the secondary coil, while IP is equal to current in the primary coil. Do you understand? So next now is to talk about transformer itself. That is step down transformer and step up transformer. You need to study them separately. Now let's understand the concept of transformer. So I'm going to clean the board. You understand? So that we start the concept of transformer. So now let's talk about step up and step down transformer. Step up and step down transformer. Let's talk about step up and step down transformer. Now, what I wanted to know here is that step up and step down transformer depends on the number of turns in the primary coil. Depends on the number of turns. Depends on the number of turns in the primary coil. In the primary coil, relative to the number of turns in the secondary coil. Are you there? So we'll talk about step up and step down transformer. We'll talk about transformers, this and this, or you say this or this. That is step up transformer or step down transformer. Step up transformer, or you say step downward transformer. Are you there? Either you say step up transformer or you say and step upward transformer. Depends on the number of turns in the primary coil relative to the number of turns in the secondary coil. Now, let's study them individually. Let's talk about step up transformer. Let's talk about step up transformer. Step up transformer. What is step up transformer? This is a transformer. This is a transformer which its size increases, or which increases, let's use the word, which increases the size of EMF / voltage applied to it through the primary coil. Full stop. Now pay attention. In order to achieve this, comma, the number of turns in the secondary coil must be greater than the number of turns in the primary coil. Now pay attention. We're talking about step up transformer. This step up transformer has a structure. Do you understand now? And it has a what? A diagram. Now let's draw the diagram. Look up. How do you draw the diagram of step up transformer? The key word you need to know here is that the number of turns in the secondary coil must be greater than the number of turns in the what? Primary coil. And this is a transformer. Look up. This is a transformer. Now we have something like this. So here we have something like this. And here we have something like this. Do you understand? So this is EX / output. Are you there? So this side, I will need space here. I will need space here. Where is that wet line? I will need space here. Look at it here. Let me expand this. So we have something of this nature. Now, we draw this. Now look up. We have something of this. So this is AC source, or you call it alternating AC source. Are you there? So this side now, we have something like this. So this is EX slash output, and this EP slash input. Are you there? Remember we said that the number of turns in the secondary coil must be greater than the number of turns in the what? Primary coil. So how do you draw the turns? Look at it here. Look at it here. Are you seeing it? We are in the secondary now. Are you there? Now, this one is output, that is secondary. So here, we have something of this nature. Do you observe now that the number of turns in the secondary coil must be greater than the number of turns in the primary coil? Are you there? Now, here we have something like this. NX greater than NP. Number of turns in the secondary coil. And IS will be less than IP. Are you there? Good. So here now is the laminated soft iron core. This is a typical transformer. This is called step-up transformer. This is step up, we made a step upward, step up, transformer. Do you understand now? Now, let's talk about the principle of operation. It has what? Principle of what? Operation. One is that when the primary coil, principle of operation, one, when the primary coil, when the AC source is connected to the primary coil, right? When the AC source is connected or applied at connected to the primary coil, III, the alternating magnetic flux, the AC source passing through the AC source passing through the coil set up an alternating magnetic flux in the soft iron core. The AC source passing through the coil sets up an alternating magnetic flux in the iron core. In the iron what? Core. Now, III The secondary coil is linked by changing the flux. You see that the secondary coil is linked by changing the flux, which induces EMF, in the secondary coil. Now IV. Now IV. Now pay careful to this IV. IV. Remember we said that setup transformer, this is a transformer which increases the size of EMF/voltage applied to it through the primary coil, right? In order to achieve this, the number of turns in the secondary coil must be greater than the number of turns in the primary coil. Is that correct? Good. Now, IV, we say that since the number of turns in the secondary coil is greater than the number of turns in the primary coil, we now see that the EMF in the secondary coil is greater than the EMF in the primary coil. Are you there? Now, V. The V. What is the V now? The V, the fifth principle of operation. The fifth one is that the output power, that is Vx, is greater than the input power, that is Vp. Are you there? Did you understand now? Now, another thing we need to know is that step-up transformer are seen, or they are located at power generation station. Are you there? Set-up transformer is applying the power transmission to set up the generated voltage before the power is transmitted over long distance. Do you understand the point now? Now, the set-up transformer is applying power transmission. Note that the setup, note that the step-up transformer is applied in power transmission station, that is in transmitting power, before the generated voltage is transmitted over a long distance or distant places. Do you understand now? So that is that on step-up transformer. Now, let's talk about step down transformer. Eh? Let's talk about step down transformer. Now let's talk about step down transformer. We have discussed step up transformer. Now let's talk about step down transformer. Step down transformer. Step down transformer. Now look up. What is a step down transformer? This is a transformer. This is a transformer which increases the size of the EMF slash voltage applied to it through the primary coil, through the what? Through the primary coil. Are you there? Now, in order to achieve this, comma, the number of turns in the secondary coil must be less than the number of turns in the primary coil. Full stop. Now look up. The difference between step up transformer and step down transformer is that in this statement, in order to achieve this, in step up transformer, the number of turns in the secondary coil must be greater. Did you understand now? But in the step down transformer, the number of turns in the secondary coil must be less than the number of turns in the primary coil. Did you understand? Good. Now, let's draw the structure of a step down transformer. The structure of a step down transformer. The structure of a step down transformer. So here is EX slash output. And here is EP slash input. Do you understand? Remember that the number of turns in the primary coil must be greater. So here we start. And here do you understand now? Number of turns in the primary must be greater than the number of turns in the secondary. Now, NX here will be less than MP, or IS here will be greater than IP. Did you understand now? Good. Don't forget that this is laminated iron core. Laminated iron core. This is a step down transformer. Are you there? Good. Now let's talk about the principle of operation. I can dictate that, or should I write again? Should I write? Now, principles of operation here. Principles of operation in step down transformer. Principles of operation Principles of operation in step-down transformer. I. When an AC source AC source is connected to a primary coil. I. The AC source, the alternating AC source passing through the coil, sets up an alternating magnetic flux in the iron core. Are you there? Now, I. The secondary coil is linked by changing the flux. The secondary coil is linked by changing the flux, which induces EMF in the secondary coil. Now IV, the fourth principle of operation. IV. Remember we said that in order to achieve this, the number of turns in the secondary coil must be less than the number of turns in the primary coil. Is that correct? We now say that since the number of turns in the secondary coil is less than the number of turns in the primary coil, the EMF in the secondary coil is less than the EMF in the primary coil. V. Are you there? V. The input power is greater than the output power. Are you there? Good. Now that we are done with step down and step up transformer, the next thing we want to look into is turn ratio. But before then, we need to talk about the step down transformer. You can say that step down transformer is used to reduce the high voltage required in homes and factories. Are you there? They are used to step down the high voltage. They are used to reduce the high transmitted voltage to lower voltage required in house factories. Now, let me write. Note, step down transformer is used to reduce the high transmitted voltage to lower voltage required in homes and factories. Are you there? Now, the next thing we need to look into is what? Turn ratio is what? Turn ratio. Turn ratio. What is turn ratio? Turn ratio is the ratio of secondary turn to primary, ratio of secondary coil to primary coil. Are you there? Turn ratio can be defined as the number of turns of the secondary coil to the number of turns of the primary coil. I said that turn ratio can be defined as the ratio of the number of turns in the secondary coil to the number of turns in the primary coil. Are you there? And turn ratio is equal to nx over np. Now, in step up transformer, turn ratio is equal to nx over np greater than 1. Are you there? In step-up transformer, turn ratio is greater than 1. You understand later when we start calculation. This is still the introduction to transformer. Now, but in step-down transformer, turn ratio is equal to n subscript s n subscript p, that is np, is less than 1. That is that on turn ratio. Do you understand? Now, the next thing I want us to look into is sources of energy losses in practical transformer. Sources of what? Energy losses in practical transformer. There are about 4. We have copper loss / heat / I square arrow loss. We have AD current loss. We have hysteresis loss, and we have magnetic flux leakage. Now, let's look into them one by one. We are wrapping up on this topic gradually. After the sources of energy losses in practical transformer, we look into the power distribution, just like generation, distribution, utilization, and all that. Then we'll talk about HVT, high voltage transmission, and that ends it. Do you understand now? No. After HVT, we also look into advantages of AC over DC. That is the end of the transformer. Before we talk about, we'll look into small calculation, then we are done. Do you understand? So stay with me. Let's continue. Pause. You can also say that the process of moving power away from power generating station through a conductor, through a what? A conductor to the consumers. To the consumers is known as transmission. Known as what? Transmission. Now the next one there is distribution. Next one now is what? Distribution. Distribution. So under distribution, we can say that this enters how power is, should I say, transmitted. How power is transmitted. How power is transmitted to the consumers in an efficient and safe way. This entails how power is transmitted to the consumers in an efficient and safe way. The last but not the least is on the word utilization. We can say that this enters, or this involves how the consumers use the power transmitted to them in an effective and safe way, because you must utilize power in a safe way, otherwise the power will utilize you in a bad way. You understand? So if you are dealing with electricity, you must be careful on how you utilize it, otherwise there will be story that touches the heart. You get? So from the word utilization means consuming what the manufacturer gives to you. Do you understand now? So the next thing we're going to look into is high voltage transmission, that is HVT. High voltage transmission. So what is high voltage transmission? So in bracket you can call it high HVT. And you know that electricity is transmitted in high voltage. When electricity is transmitted in high voltage and at low current, what do you do? What do you do? When electricity is transmitted at high voltage and low current, that means, is there a problem to that? We need a step-down transformer to should I say, to control the power transmission. In Nigeria, we hear up NEPA, you get, and then we also hear low current. They can be reduced when you have high voltage transmission. It can be reduced with the step-down transformer. And remember, step-down transformers are transformers that are needed for homes and factories. Do you understand now? Step-down transformers are transformers that are needed for homes and factories. Why step-up transformers are the transformers that come from power generating station. Did you get? When power is transmitted in high voltage, is it in or at high voltage and low current? When power is transmitted at high voltage and low current, comma, step down transformer is used to reduce the what? It's used to reduce the what? Is used to do what? Is used to reduce the power so that it will be ready for consumers to utilize it. It is used to reduce the power so that it will be ready. It is used to reduce the power so that consumers can readily utilize the power. But the essence of high voltage transmission is to reduce power loss. Is to do what? So the main key point here is that high voltage transmission is mainly used to reduce power loss. Are you there? It's mainly used to do what? Reduce power loss. So when there is power transmission at high voltage and low current, step down transformer will be employed to do what? To reduce the power so that consumers can, let's say, to use the power or electricity so that it can be ready, consumers can use it, or the power can be ready for consumers to do what? Utilize it. Did you understand now? Now let's talk about advantages of AC over DC. Advantages of what? AC over DC. Advantages of AC over DC. AC over DC. First of all, what is AC? AC means alternating current. Why DC means what? DC means direct current. So one of the advantages is that it is easily or cheaply step up or down by a transformer. I'm talking about AC now. It can be easily or cheaply step up or down by a transformer. Are you there? You can see that it can be cheaply or easily step up or down by a transformer. It can be easily step up or down by a transformer. We'll talk about advantages of something over this. What does that mean? That's why the why this one is what? Do you understand the? It minimize it minimize loss of heat, in brackets energy, which can be transmitted over a long over a long over a long distance over